Hi, this is Alex from devstories.eu. CircuitPython, Episode 3 of 7. Most embedded debugging involves tweaking a line of code, waiting for a recompile, flashing the board, and hoping your output log catches the bug. But what if you could pause execution and command the hardware live? That is exactly what the Serial Console and REPL allow you to do. When you connect a CircuitPython board to your computer, it establishes a two-way serial connection over USB. You can access this using a terminal program like PuTTY on Windows or the screen command on macOS and Linux. Many serial connections require you to match a specific baud rate, typically 115/200. CircuitPython actually ignores this setting over USB, but it is standard practice to configure your terminal to that speed anyway. The Serial Console is your primary text-based window into the board. Whenever your script executes a print statement, the output appears here. More importantly, if your code encounters a fatal error and crashes, the Python traceback is printed to this console. Without a serial connection open, a crashed board gives you no diagnostic information. It simply stops working. The Serial Console is also your gateway to the REPL. REPL stands for Read, Evaluate, Print, Loop. It is an interactive Python prompt running directly on the microcontroller chip itself. Traditional firmware development requires writing code on a host machine, compiling it, and transferring the binary. The REPL changes that dynamic entirely. You type a command, the board reads it, evaluates the logic, prints the result, and loops back to wait for your next command. Consider a practical scenario. You have a script running on your board, but you need to figure out which hardware pin controls the built-in LED. You open your serial terminal and press Ctrl-C. This instantly interrupts the running script. You're prompted to press any key, which drops you into the REPL. You know you're in the right place when you see the standard Python prompt, which is 3 angle brackets. Now you type import board. To discover what hardware is available, you pass the board module into the built-in dir function. The REPL prints out a list of every active pin name for your specific hardware. You see the LED pin in the list. Right there at the prompt, you import the digital I/O module. You create a pin object for the LED, set its direction to output, and set its value to true. The physical LED on your desk instantly turns on. You just commanded the hardware manually, one line at a time. Here is the key insight. Code typed in the REPL is ephemeral. It only exists in the active memory of that current session. If you unplug the board or restart it, everything you typed vanishes. The REPL is an exploratory tool. It is a sandbox where you can test hardware limits, verify pin names, or check syntax on the fly. Once you find the exact sequence of commands that achieves your goal, you must manually recreate that logic inside your code.py file on the USB drive to make it permanent. When you're done testing, you exit the REPL and restart your saved code by pressing Ctrl-D. This triggers a soft reboot, reloading your code.py file from scratch. The REPL shifts hardware development from a slow cycle of guessing to instant interactive exploration. Thanks for listening. Happy coding, everyone.